Hey guys, this is Mr. Sal. We're going to look at rate of change in a linear relationship. Alright, let's go through each of these from this first problem. Number one, the graph below shows the distance the cat is from his bowl of milk over time. Which sentence is a good match for the graph? Let's go through all five of these, alright? Part A, the cat was 12 feet away from the milk and ran towards it, reaching it after 4 seconds. Part B, the cat was 4 feet away from the milk and ran toward it, reaching it after 12 seconds. Part C, the cat ran away from the milk at a rate of 3 feet per second. Part D, the cat ran away from the milk at a rate of 4 feet per second. And Part E, the cat was 12 feet away from the milk and ran away from it at a rate of 4 feet per second. All right, take a minute with your neighbor and discuss which of these five would best represent this graph. Let's go through this one. Now let's look at the graph and analyze it first, which hopefully will help us determine which of these is best. So the first thing on this one, and just from the words it said, so the distance is how far away the cat is from the bowl of milk. So that means that at 0 distance, that would represent the bowl of milk. But also, this is 0 for 0 seconds. Now that 0 would represent how far the cat was in the beginning, right? Because we do have that point on this line right here, which is 0, 0. That's the origin. So that 0 represents 0 seconds, which means at 0 seconds, the cat was at the bowl of milk. Now this ordered pair that they gave us up here, the 4 is in seconds, because that's the x value on that one, and the x represents seconds. But also the 12 is representing distance away from the bowl, so that would be 12 feet from the bowl of milk. Also, this line is straight, so we know that the cat is traveling at a constant rate of change. And we should be able to figure out what the constant rate of change is just from the graph as well, okay? Something else we may notice about this is that the line is straight and goes through the origin, so we know that it is a proportional relationship. So let's look at those five again. So on this one, part A, it says the cat was 12 feet away from the milk and ran towards it, reaching it after 4 seconds. So that means it would have to start here and then run towards the milk, something like this, okay? But that isn't shown. So we know it's not A. Part B says the cat was 4 feet away from the milk and ran toward it, reaching it after 12 seconds. So that would be starting at somewhere like here. That would be 4 feet away and then traveling towards it, reaching it at 12 seconds, something like this. Okay. But that didn't happen either. So it's not part B. Part C, the cat ran away from the milk at a rate of 3 feet per second. So based on the blue line, we know it's running away from the milk, but we don't know, or we didn't figure out what the rate of change is actually, okay? Well, here's what we know. It's proportional. So at 12 feet, the cat was at 4 seconds, the cat was 12 feet away. So if we were to simplify this, you would get 3 feet for 1 second. That would be the rate at which the cat is traveling away from the milk. And that does match up with part C, but let's look at the other two just to make sure. Part D, the cat ran away from the milk at a rate of 4 feet per second. No, we know that's not true because it's traveling at 3 feet per second. And then part E, the cat was 12 feet away from the milk and ran away from it at a rate of 4 feet per second. No, it did not start 12 feet away from the milk. So this one also no good. So that helps us to determine that the answer would be C. All right, part 2, write everything you can say about the cat and the distance he is from the milk during this time. We already did that on that last problem. create a table at the right which also tells the story of the graph. Okay. Take 1 minute and do that with your neighbor. So here's what we know on this. For all tables, the x values should generally be on the left, and the y values should be on the right. And the x values in this graph are represented by time in seconds, and the y is represented by the distance in feet. From here, we can, even in the beginning, right, we know that at 0 seconds, the cat was 0 feet away from the milk bowl. But since it's traveling at 3 feet for every second, then after 1 second, we would expect it to have traveled 3 feet. Then after another second, it should have gone 6 feet from the bowl now. And then 3 seconds means another 3 feet, and 4 seconds means another second means another 3 feet. Okay. Now from this, we also did confirm that the point 412, which was on the graph, is also in the table right there at 412. That's just by using the rate of change to figure that out. Is this a proportional relationship? Justify your answer. Yes, this is a proportional relationship because it's a straight line that goes through the origin. Find the unit rate in the story. We already did that. Let's show it in the table though. So I know that I'm adding 3 feet there for every 1 second. So we know it's a 3 feet for 1 second unit rate. Alright, number 6. Sketch a graph for each of the 4 stories from number 1 on the previous page, which you didn't choose. That was A, B, D, and E. Label the graphs by letter to match the story. Find the rate of change for each story as well. So we're going to find the rate of change. And this one that we're going to start with is story A, and then do B, and then D, and then E. Do those with your neighbor. We'll give you guys a couple minutes for those. Alright, part A. The cat was 12 feet away from the milk. That means it would have to start at 12 feet away. That's the distance of 12. And then it's going to run towards it, and it reaches it at 4 seconds. That means it has a distance of 0 at 4 seconds, which is this point. From here, all I need to do now is to connect these 2 points to make a line. There we go. So this line would be the graph that represents A. Now on each of these, it asks also for the actual rate of change on these. So let's go ahead and write those in. This one, it went down 12 feet, or 12 feet closer, in 4 seconds. So that's negative 12 feet for 4 seconds. And this one can be simplified so that we would get negative 3 feet for 1 second. On part B, the cat is 4 feet away from the milk. So that's how it's going to start, at 4 feet away right there. And it's going to run towards it, reaching it after 12 seconds. This is 12 seconds right here. And it's reaching the milk because that has a 0 distance. And then once again, all we need to do at this point is connect the 2 points. So this graph would represent the part B from that first one. The rate of change on this one. So this one is going to go down 4 feet for 12 seconds. So I would write this as negative 4 feet for 12 seconds. But what we really want to know is how far this would be for 1 second. We could simplify this. It'd be negative 1 foot every 3 seconds. So it should be negative 1/3, that's feet. Negative 1/3 feet for every 1 second. On that day. This would be the unit rate of change for situation B. So part D, the cat ran away from the milk at a rate of 4 feet per second. What this means is that it's going to start at the milk. So there's 0 seconds and 0 feet away from the milk. But it's running away at 4 feet per second. So we're kind of using this as a unit rate. It's going to go 4 feet in 1 second. So this would be our second point on that. And that pattern is going to continue It's going to go up 4 feet for 1 second, 4 feet for 1 second. And then once again, we'll connect these points with a line. On D, this one, we've already seen, and it told us that the cat was traveling at 4 feet for 1 second. So that's our unit rate for this one. All right, part E, the cat was 12 feet away from the milk and ran away from it at a rate of 4 feet per second. On this one, it's going to start 12 feet from the milk, and then it's running at 4 feet per second, so it'd be 4 feet and then 1 second right there. And that would give us this line or something like it. Okay. Now we can't fit all this line on here because of where it starts on the graph. It just hopefully we understand that this is what the graph would look like if we had read this story. And then part E as well, it told us here at the bottom that the cat was traveling at 4 feet per second. Number 7, a baby was 9 feet from the edge of the porch. He crawled toward the edge for 6 seconds. Then his mother picked him up a few feet before he reached the edge. Circle the graph below that matches this story. Take 1 minute and discuss this with your neighbor. If we were to analyze these, so the y-axis represents distance and the x-axis represents time. This one indicates that the baby started at the edge and then moved away from it. So it can't be this one. This one indicates that the baby stayed essentially 2 feet away from the edge of the porch, which is no good. On this one, it shows that the baby starts 9 feet from the edge and then in 9 seconds actually gets to the edge, which is, again, no good. On this one, it starts 9 feet from the edge, and then 6 represents seconds. The 2 is feet away from the porch, and that's when the mom picked him up. So it would be this one. The graph and table below describe a runner's distance from the finish line of the last seconds of the race. Which equation tells the same story as the table and graph? Use the order pairs given in the table to test your chosen equation and explain your choice. Now, take 30 seconds to do this one. For this one, there's a couple ways to look at it. You can use the table or the graph. In the table, we can choose any 1 second and figure out how it changed. So let's use these two. Not that it would matter. But I can see the distance goes down 7 meters as this went down 1 second. So that would be our rate of change on that one, right? I'm sorry, that went up 1 second. So the rate of change on this would be negative 7 meters for 1 second. Which would be part of the equation, right? The distance would equal the rate of change, which we could simplify to negative 7, multiplied by x, which is time, and then its starting value, which is shown in the graph right here, and in the table here. The starting value is at 42. So I would add 42. Now this exact choice is not on this, is not one of these options exactly. But if we switch around those two, then we get C on this one. All right, 9 and 10, create a table for this graph and then write a story for this graph. 1 minute on this one, go. Create the table for this graph. Nice thing is they gave us this first point. When the time is 0, it's a distance of 5. And then also at a time of 3, the distance is 23. So we can fill this in with 1 and 2. We just got to figure out what these values are. And to do that, we got to find the rate of change. So the distance went up by 18 because it starts at 5 and goes to 23. And then the time changed by adding 3 of whatever units that is, and it didn't say. We'll have to determine that in the story part on this. So it's a positive 18 distance for every 3 in time, which would simplify into 6. So for every 6 distance, you would have 1 in time. So from the 5, we'll add 6 to make that 11. And then we add another 6 to make it 17. And then the other 6 would make that 23. So it is consistent on this one. And it should be because it's a straight line. So this would be the table, the graph. There's several different ways we can look at this. I'm going to say that the distance is in miles, and the time, we'll just say is in hours, not that it matters. But the story for this one, I'm going to say that a student was starting 5 miles away from home, and then walked 6 miles per hour away from home for 3 hours until they reached 23 miles away. Okay, so I'll write that in. Number 11, which equation matches this story? Your story, the graph, and the table. All right, so there's the table and the graph. On this one, we've already seen that the rate of change was 6 distances for every 1 in time. So it couldn't be this one, or this one, because it's 6 multiplied by the x. Also, we see that there are 5 distances away from when the time is at 0. And that's where that plus 5 is in this equation.